Okay, so this episode here is going to talk a little bit about the differences between velocity-based training and velocity-based analysis. Often when we hear the word anything with the word velocity in it, we often think fast, explosive movements, but this is not always the case. Velocity-based training has been used synonymously with velocity-based analysis. However, I think it's important to make the distinction between what we consider velocity-based training and what should be considered velocity-based analysis. Thanks to a lot of the recent literature that's come out over the past 10 years, we've been able to determine that in multi-joint compound movements, the linear relationship between force and velocity exists, which is a little different than what was initially found when they tested it on a single muscle fiber of a frog, as done by Hill in the 1940s. The recent advancements in understanding of the force velocity profile dynamic movements allows us to use this relationship to better understand training. Because we know there's a linear relationship between force and velocity, you can establish a force velocity profile of an individual through a series of repetitions at maximal intent, ranging in loads between 30 to roughly 85% of their 1 RM. From there, you can get a linear relationship and regression from those numbers, and you should be able to predict their projected 1 rep max based on their minimal voluntary threshold. So their minimal voluntary threshold, also known as a MVT, is just a fancy word for saying the velocity at which a 1 rep max of that specific movement occurs at. Thanks to the relative stable nature of these MVTs, we're able to project the linear force velocity profile all the way from unloaded to 100% of their 1 RM. So the awesome part about force velocity profiling is that it is stable, and because it's stable, we can essentially use the force velocity relationship of an individual as a checks and balance system for their training. So this is where velocity-based analysis comes into play as opposed to velocity-based training. We use the velocity to analyze the percentages we assign to the athlete for that given day, and based on the velocity they are moving the given percentage of 1 RM at, we can determine whether or not that prescribed percentage of 1 RM accurately reflects the desired prescribed percentage of 1 RM given to the athlete. So for example, if an athlete moves 50% of their 1 RM at 1 meter a second, and the athlete has a squat of 300 pounds, that means we'd expect them to lift 150 pounds at 1 meter a second. So because we know the athlete is going to lift 50% of their 1 RM at 1 meter a second, we can have the athlete come in that day. We can assign a percentage of 50%. We can have them load the bar up with 150 pounds. But let's say all of a sudden you now see that the bar is only moving at 0.9 meters a second. As a coach, you can now auto-regulate the training, and you can prescribe a load that's going to induce a bar speed of 1.0 meters a second. So maybe you have to reduce the load by, say, about 10 pounds. Now you've used velocity-based analysis to help make your training auto-regulatory instead of guessing what percentage of 1 RM the athlete is actually moving the bar at based on the velocity. So in essence, velocity is acting here as a checks and balance system to your prescribed percentage of 1 RM, which then allows you to make your training more accurate. This is different than velocity-based training, which is often associated with moving loads fast. So velocity-based training can be done with velocity-based analysis, but velocity-based analysis does not mean that it's high velocity training. For example, you can use velocity-based analysis to train maximal squat strength. However, you're not going to train maximal squat strength using high velocity movements. The small distinction would help clear up some of the confusion in the field because velocity-based analysis has much more depth to it than does velocity-based training. Velocity-based analysis can be used to measure the neuromuscular state of the athlete for a given day. It can acutely measure adaptations and chronic adaptations to training. It can give you an idea of the athlete's percentage of 1 RM that they should be lifting for that day, It can give you an understanding of what their true max strength is for that day. All this can be done with velocity-based analysis. However, velocity-based training is often associated with moving the bar fast and not necessarily using velocity to analyze the actual training itself. Thus, velocity-based analysis and velocity-based training should be distinctly understood as two different entities. I think the small distinction between velocity-based analysis and velocity-based training will clear up a lot of the confusion that's currently going on in the field. The idea of velocity-based analysis will open the door to people looking at how velocity can be used to analyze training, get an understanding of the acute changes that are occurring, whether it's metabolic accumulation and fatigue, whether it's neuromuscular fatigue, whether it's chronic or acute neuromuscular adaptations. Velocity-based analysis has the potential to go much further, while velocity-based training is much more predicated on high-velocity movements, possibly directed more towards power output improvement and increasing transfer of training through velocity-specific means. I hope you guys enjoyed the talk today. I think it's an important distinction to make in this field. Yeah, it might be small, but it has a very important role in clearing up some of the confusion. Thank you very much for listening. Hope you guys liked it.